Okay, so let's unpack this. If you went through any kind of engineering or science training in the West, you learned one really powerful fundamental rule,
Hmm.
that simplicity comes from separability. To understand a system, you have to break it down.
Right. You break it into clean, independent, orthogonal components.
Exactly.
It's really the success story of history, you know?
Right.
Think about Cartesian coordinates, x, y, and z are totally independent.
They don't care about each other.
Not at all. Or modular design in engineering, or how you isolate variables in an experiment. This whole idea, this independence thesis that things have intrinsic properties separate from their relationships, it's been incredibly productive.
And it has served us brilliantly for, what, centuries? But here's where it gets really interesting. This is the focus of our source material today. The paper Aperture Orthogonality, a philosophical examination. It argues this foundational assumption fails. And not just fails, but fails spectacularly in what are called relational systems.
Right. These are systems, like quantum physics or even a modern company's structure where the components actually co-define one another.
Their identity is their relationship.
Exactly. And when you try to force that old method, that classical separability, onto these systems, well, the paper says you create conceptual distortions and systematic blind spots. You're just fundamentally missing the point.
So our mission for this deep dive is to get into the core thesis of this paper. Orthogonality isn't a property of reality itself.
Right.
It's a property of our perspective, of the apertures we use to observe it. We're going to unpack how a unified, entangled reality can still be described simply, but only if you choose the right set of complementary views.
And this is not just some abstract philosophy. For you, the listener, understanding this inversion, how two seemingly separate ways of describing the world are really just projections of a single thing. That's the key to defining what true simplicity is.
Let's start with where that classical view actually works.
Yeah.
You mentioned linear algebra, Newtonian mechanics. Why does the idea of independent parts hold up so well there?
Well, because in those domains, the entities really do seem to possess intrinsic properties. The mass of a planet, for instance, just sort of exists. It's there whether or not it's interacting with another planet.
So you can decompose the system, describe the parts, and then add in the forces as these, like, external connections.
You got it. In those cases, the assumption of separability is actually a pretty good model of the system's structure. It works.
But the second we step into these relational domains, that whole model just breaks down. What's the key difference?
The source of identity. I mean, that's the whole thing. In a relational system, an entity's identity is defined only by its place in the network. If you try to analyze an organizational role, say chief operating officer, as this standalone thing, you completely fail.
Because that title means nothing without the CEO, the supply chain, the whole team.
Exactly. The relationships are constitutive. They aren't just added on later. They create the thing itself.
So if our main tool, separability, is broken, we need a new one. This is where the paper brings in this concept of the aperture. What is that exactly?
An aperture is basically a deliberate act of selective attention. Think of it like a lens or a filter. It's a framework you use to project a really complex, high-dimensional reality onto a simpler, descriptive space.
So you're taking this tangled knot of information and using an aperture to make it manageable so our minds can actually grasp it.
Precisely. And the paper's huge insight is that the orthogonality, that independence we value so much, it actually describes the relationship between these lenses, not the knot itself.
So it's an artifact of our method, not a feature of reality.
You've got it.
Okay, to build this idea, the paper focuses on two of the most fundamental perspectives we can take, ontology and manifold. Let's start with aperture one. Ontology, the aperture of being.
Ontology asks that, the simplest and oldest philosophical question, what exists? What kind of thing is it?
The inventory list.
The inventory list, perfect. For system analysis, it identifies the primitive existence. It gives you the categories, the identity conditions. It is the minimal description of being.
And the key feature here is what it ignores, right? What does it intentionally leave out?
It leaves out motion, time, interaction, all relational structure. It achieves its simplicity by suppressing all of that. So if you're building an ontology, you're just cataloging particles or defining roles in a company or listing the basic parts of a computer. It's a static snapshot.
Okay, so ontology is the static catalog of things. Now let's flip that coin. Aperture 2, the manifold, the aperture of relation.
The manifold describes the container, but not what's in it. It asks, what's the structured space where things exist and relate? It's a term from mathematics, and it defines the rules of the road for interaction.
The topology, the geometry.
Right. The dimensionality, the allowed transformations. It's the minimal description of the interaction structure.
So if ontology is the inventory, the manifold is the operating manual, the rule book for how that inventory can behave.
Exactly. And the crucial thing here is that you can describe the manifold without knowing what's in it. You can map out the geometry of space-time or the reporting lines in a company without needing to know the name of the person or the particle in those positions. It just describes the space of what's possible.
The classical way of thinking, for, centuries, just assumes these two things, the stuff and the space, are separate inputs. We put the material into the container of absolute space.
Which the paper calls the classical error. It comes from this, what they label substance container metaphysics.
That sounds intuitive, though, the idea that the substance is separate from the space holding it.
It's very intuitive. But in truly relational systems, it's a fiction. You have to look at the core relata relatum structure.
Relata being the things, the entities, and relatum being the relation itself. So how is that different from just objects connected by wires?
Because the entities, the relata, aren't pre-existing. They are defined through the relations. The relation isn't external, it's what makes the entity what it is. The best example is probably quantum entanglement.
That's a great one. With two entangled particles, their individual states, their ontology, just don't exist on their own.
Precisely. Their being is defined by that shared unified quantum state, the relatum. You can't define particle A without particle B. They are mutually generative.
They actively create and constrain one another. Let's break that down. How does the ontology, the list of things, constrain the manifold, the space?
Well, the very structure of your entities generates the geometry. If your entities are discrete, say, like people in a line, they generate a specific topology of interaction, a discrete one-dimensional manifold. The categories you define for your entities create the architecture of the relational space.
Okay, and what about the other way? How does the manifold determine the ontology?
It acts like a filter. The geometry of the space determines what kinds of things can even exist there. If the rules of your system, the manifold, forbid localized independent states, which is what we see in modern field theories, then the manifold itself reveals that what you thought were separate little entities are really just, ripples or excitations of a single continuous field. The space constrains the forms of being.
So this mutual generation means they have informational overlap, they're describing the same reality, their descriptions are intertwined, but the paper insists they are irreducible. That feels like a contradiction.
It does, but it's not. They're irreducible because they answer two fundamentally different questions. Knowing how things can relate, the manifold tells you nothing about what they are categorically, the ontology.
And vice versa.
And vice versa. They give you complementary, non-redundant information. That combination of overlap and irreducibility is the telltale sign of a deeply relational system.
Which brings us to the big aha moment, the canonical insight. We have this tangled, unified system, but we need simple, distinct ways to talk about it.
And the critical inversion is this. We make a category error. We project the orthogonality of our perspectives back onto the system.
Oh, I see.
The system itself is a unified whole. The appearance of independence, of this clean separation between what is and how it relates, that's just an artifact of the filters we're using.
The system isn't separable, but our views of it are designed to be orthogonal for simplicity's sake. And the paper has 4 conditions for ontology and manifold to be orthogonal as apertures. What are they?
First, ontology gets its simplicity by suppressing all the relational stuff that the manifold reveals.
And second, the manifold gets its simplicity by suppressing all the categorical existential stuff that the ontology reveals.
Exactly. They each achieve compression by being intentionally blind to what the other is good at seeing.
Okay, so that's 1 and 2, selective filtering.
Third, they have to be sufficient. Together, they have to give you enough information to reconstruct the whole system. No major gaps.
And number 4 is the one that really clears up that overlap confusion. How are they informationally independent?
They're independent because knowing everything about one framework tells you literally nothing about the suppressed information in the other. You can know the precise geometry of a manifold, the complete rulebook, and still have zero information about the categorical nature of what's going to populate it.
So this resolves the tension. They are informationally overlapping in reality, but informationally independent in our representation. And that completely changes how we should define simplicity.
It does. It means we have to throw out classical simplicity, which is just, simplicity equals separability. That just doesn't work for these systems.
Instead, we move to something called relational simplicity. What's the difference?
Relational simplicity means a system is simple if it can be completely described by the fewest possible number of orthogonal apertures. The goal isn't to maximize modularity anymore. It's to maximize complementary projection.
Like taking two perfect X-rays of a complex crystal from different angles. You don't break the crystal. You just find the two views that together show you everything.
That's a perfect analogy. And ontology and manifold are those two minimal views because they capture the two irreducible sides of that foundational relata-relatum structure being an interaction.
This isn't just philosophical tidiness. This is a really powerful diagnostic tool. Let's talk about organizational physics.
Right. An organization is a fundamentally relational system. The roles and responsibilities, that's the ontology. The reporting lines, the communication channel, that's the manifold. And the paper suggests that most dysfunctional organizations suffer from aperture incoherence.
Give us an example of that incoherence.
Okay, imagine a company where the official reporting structure, the manifold, is a strict, slow hierarchy, 5 layers of approval for everything.
I think we've all seen that movie.
We've all been in it. But the roles, the ontology, are defined as needing immediate, agile, cross-functional collaboration.
So the manifold says slow and vertical, but the ontology demands fast and horizontal.
Exactly. The system is incoherent. The entities, the roles, don't generate a relational architecture that supports them. The parts and the rulebook are misaligned. It's guaranteed to create friction and failure.
That's incredibly useful. Now, what about fundamental physics and the wave-particle duality?
This duality, which has been held up as this great quantum mystery for a century, becomes almost obvious with aperture orthogonality. The particle view is the ontology.
It's localized, it's a discrete unit, it has an identity.
Right, and the wave view is the manifold. It's continuous, it's relational, it describes the field geometry and the space of possible interactions.
So it's not two competing realities, it's two orthogonal, complementary views that when you put them together, describe the whole quantum fabric.
It just dissolves the tension. The job of a physicist isn't to figure out if an electron is a particle or a wave. The job is to find the unified description that generates both of those orthogonal perspectives.
Which means the lesson for system design, for what the paper calls cosmogenic practice, building coherent artificial universes like software or companies.
The goal shifts completely. It's not about maximizing the modularity of the parts. It's about maximizing mutual generation. You have to design it so that the entity types, the ontology, naturally imply and generate a coherent set of interaction rules, the manifold.
So if we step back, the big takeaway holds. Ontology and manifold are the two simplest irreducible apertures, not because they are independent in reality, but because they are the minimal, mutually generative projections of that core relatum structure.
The search for knowledge has to change. You have to stop asking, what are the independent parts? That's often the wrong question. You should start asking, what are the minimal set of orthogonal views I need to reconstruct this unified structure?
The deepest simplicity is in that minimal set of complementary projections.
That's it.
And here's a final thought for you to carry away from this deep dive. If our own minds, our bodies are identities, they are deeply relational systems where function and structure define each other. This is the whole mind-body problem, just another case of aperture incoherence. Is it just a result of treating the mind, maybe a functional manifold of processes, and the body, the material ontology of cells, as two separate realities when maybe, just maybe, they are complementary, mutually generative projections of a single living fabric? We'll leave you with that to explore.